All right. All right, guys, we're moving on to our next video, which is about probability again. So we're still in the probability unit. Sorry, John's cooking, so if you hear noise in the background, sorry. We have to live, right? So the next one is called compound probability. Okay. And our EQ for compound probability is which method do you prefer? And why? All right, so I'll go ahead and let you have time. You could pause the video now and write this down. So compound probability, which method do you prefer and why? Okay, I'm gonna make myself a little bigger. So a compound in science is when you combine two or more things. So compound probability, just so you guys know, it's kind of like the same thing in math. It's so compound probability is at two or more events happening. Two or more events happening, okay? So it's when you're looking at the probability when not just one thing is happening. The example I will use a lot is flip one coin, roll one dice. So in compound probability, you're looking at all the possible options that can happen when you're doing two things or more at once. Now, sometimes that can get a little overwhelming. At the very end of this, I will teach you a fast way to do this, okay? And I know you're like, why don't you just teach me the fast way now? It doesn't work that way because then you will understand why it works. So I'm going to teach you 3 different methods for how to do it the kind of slower way to see each event. And then I will teach you the fast way of calculating the total possibilities, okay? So let's go ahead and do this first practice problem that Miss Hinch wants to do. The flip a coin, roll a dice. So if you were to come up with all the combinations that are possible when flipping a coin and rolling a dice, think of how you'd go about doing that. Well, one way that works is called a list. You could simply just list them all, okay? So, you could get a heads and a 1. You could get a heads and a 2, heads and a 3, heads 4, heads 5, heads 6. You could get a tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. There's no other combination out there. The benefit of a list is you're able to see every single option. You're able to see them. So we know that there are 12 total combinations, or 12 total possible events, okay? So if someone was to ask you, what's the probability of flipping a heads and a getting a 2, you could say, okay, remember probability is the total times it can happen out of the total. So if someone asked you what's the probability to get a heads and a 2, that occurs 1 time out of 12 total possibilities. So the good thing about a list is you're able to see every single thing out there. So that happens 1 time out of 12 possibilities. Okay, that's one method. Another method outside of the list that people like to use is called a tree diagram. Tree diagrams are kind of fun, but they get a little complicated. I'm a list person because, Miss Minch, I like my lists and my documents and everything. So I like to use the list, but some people like tree. They think it's more visual. So in a tree diagram, you pick one of your things that you're looking at. So the first thing we looked at, I said, was flip a coin. So when you flip a coin, you have 2 options. You have a heads or you have a tails. So the first thing you do is list out those 2 first options. So that you can either, here's your little body, you can go heads or you can go tails. Now off of each of those though, you have something happening. Off of the heads you could get a 1, off of the heads you could get a 2, off of the heads you could get a 3, off of the heads 4, 5, and 6. Ooh, I'm going to move my T down. I used a lot of room on that one. So for my tails, do I have the same possibility for my tails? I sure do. So 1, 2, 3, 4, 5, 6. You can count then the number of stems coming off or your total combinations. So if we count, we have 1, 2, so heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So 6 and 6 is 12 total. And if someone asks you the same question, what's the possibility of getting a heads and then a 2, you could go, okay, heads and 2. That happens 1 time out of 12. I'm going to show you a different way to do tree diagrams in just a second. I'm sorry, another way to use tree diagrams when there's 3 events happening. It kind of changes it, but I like that too. Okay. So again, you could list out the total combinations. You could do a tree diagram. My least favorite of them is what's called the table method. Now you might think Miss Minch always makes tables into things, but table method's only good because you can only do it when there's 2 events. These 2 things up here, they list method and the tree diagram method, you can use when there's more than 2 events happening. So that's the kind of benefit of those 2 systems. But the table only occurs, or it's only possible when you have 2 events. So what a table would look like is you would take your first event, which we know is flipping a coin. So that's going to be my rows. So tails, heads, my 2 rows, I'm sorry. And then my columns would be my other thing that's happening. 1, 2, 3, 4, 5, 6. And then in each cell of a table, that's what the inside of a table is called. It's good jargon to know when you work on the computer stuff. Okay, the inside, this would be tails and 1. This one here would represent the tails in the 2 spot. This right here would represent the tails in the 3 spot. Tails in a 4 spot. Tails in the 5. See, I'm matching up tails and 5, and this last one will be tails in a 6. Then I bet you could guess what goes here, heads and 1. Here would be heads and 2. Here would be heads and 3. Here would be heads and 4. Here would be heads and 5. And here would be heads and 6. So it's kind of like a list method, but people like to do it so they can make sure that they match up every single column with every single row. This allows you to know that all your tables, they match up, okay? So tails in 1, tails in 2. So then the same thing, you can count 12 cells, so 12 total. And if someone asked you what's the probability of getting a heads and a 2, heads and 2 happens 1 time out of 12. So the probability is 1/12 of that happening. Okay. Now I'm going to go through this with you guys with I'm going to do a tree diagram and a list with you with 3 events happening. And then we're going to go ahead and learn the quick way. Okay. Some of you might already see the quick way, but shh, don't tell anyone. Okay. So we're going to try the tree diagram and the list with an event that has 3 possibilities. Okay. Okay. So an event that has 3, I like to use this because, I like ice cream. I'm like a total food person. I'm driven by food. I talk about food all the time. I love food. Might have gained some weight in this quarantine. Gotta buy some new pants. Not a good thing. Okay, so another example of using the tree in the list is when there's 3 or more. So one I like to use is Froyo. If I go to Sub-Zero Swirls, I'm going to limit the amount of real toppings that they have just for the sake of ease. But let's say they had 3 Froyo or 4 Froyo flavors at the time. So Froyo flavors, the actual Froyo, the like frozen yogurt, Froyo flavors. And let's say they had chocolate. Let's say they had vanilla. I'm going to use my favorite because I'm the math teacher and I get to pick. Cake batter. Okay, and then I'm frozen. Oh no, please come back. Communication is unstable. Restart it. Oh no, please don't do this to me. Well, kids, we're going to pause right there and I will finish in a second.